All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to learn how to find fractional distance in 2 dimensions. This is the homework assignment right here. It consists of 3 problems, but don't let that fool you because these 3 problems can be somewhat involved. Let's dive right in. We're going to take a journey today. These are fun. Because they're easy to visualize, right? So in the first problem, we're talking about campsites. And in the second problem, we're going to take a road trip from Palestine all the way to San Francisco. Okay? And then after that, we are going to go exploring inside a cave. We're going to explore the massive Carlsbad Caverns. All right, and we're going to travel through it and learn about some of its features. Okay, so there are a lot of fun things ahead in this video. So I hope this brings to life what you can do with geometry. This is a fun section, and it concludes Unit 1. So I think it's a fun way to tie off the unit, learning about fractional distance in 2 dimensions. So the basic outline is we're going to do exactly what we did for fractional distance in 1 dimension, but this time we're going to just add in the y-axis. Okay, we're going to move in 2 dimensions. And once you see how this is done, if you've been paying attention to fractional distance in 1 dimension, you'll notice it's very similar, but now you actually have to think strategically about which direction you're going, up, down in the y direction, and left, right in the x direction. So we'll just go through it. You'll learn as you go. Okay, so it says here in number 1, you are at a campsite A located at -4, -9, and your friend is at campsite C located at 7, 8. You and your friend agree to meet at the picnic tables near campsite B, which is located 4/9 of the distance from your campsite to your friends. What are the coordinates of the picnic tables? Okay, it's amazing that we can even do this, and I'm as shocked by it as you might be. The basic structure of how we begin is the same. First, we plot the points that we are given. So first, we're going to plot campsite A at -4, -9. And I'll probably have to move this image around quite a bit since this is a big graph. But -4, -9 is located here at -4 on the x and -9 on the y. That would be this point right here. Okay, and we'll call this here A, open parentheses, -4, -9, close parentheses. And when we're dealing with these word type problems, it's fun to label the points. This is campsite A, your campsite. All right, so we've labeled campsite A, and now we're going to travel to campsite C, which is located at 7, 8. So we're over here in campsite C at 7, 8. So 7 on the x, 8 on the y, right here. And so this will be campsite C, open parentheses, 7, 8, close parentheses. And we should label this campsite C. Okay, just so we've got it labeled. So let's look at these 2 points. You see campsite A is down here and to the left, and campsite C is up here and to the right. All right, so we want to find a point that is 4/9 the distance from here all the way to here. We want to find 4/9 the distance, and we want to plot that point wherever it is. So a couple things to notice. In order to get from campsite A to campsite C, we're going to move to the right on the X direction, and we're going to move up in the Y direction. So that means we'll be adding. Okay, so as we do this, we're going to be adding our fractional distances on the X and Y to the positions of campsite A in order to find campsite B, which is going to be located somewhere in here. So let's show the math. What math is involved to do this? All right, well, here's how you do it. The X coordinate of campsite B, and you write that X sub B, is equal to whatever the coordinate is for campsite, the X coordinate for campsite A. So we'll call this X sub A for the X coordinate of campsite A plus, because we said we're going to be adding, we're going to be moving to the right, so we're adding. And now we do our fractional distance component. Open parentheses, absolute value bar, and now we have to find the difference between the X values of campsites A and C. So we'll say X sub A minus X sub C. All right, so X sub A minus X sub C. Okay, so this is the difference of the X coordinates of the two campsites. Close that absolute value bar and then multiply by the fractional distance, which is 4/9. 4/9. Right, and then close that parentheses. All right, and so now it's just a matter of plugging in the values. X sub A is -4 plus, open parentheses, absolute value, and now we want to put the X coordinate of A, which again was -4, minus the X coordinate of campsite C, which would be 7, absolute value sign, times 4/9. Close parentheses. All right, so we'll just keep rolling. So equals -4 plus, open parentheses, and then -4 minus 7 is -11. And so we're going to take the absolute value of -11, which gives us +11. So the absolute value of a negative number is a positive number, and the absolute value of a positive number is just a positive number. We're only making it positive. Okay? Because you can't travel a negative distance. That's the basic idea. And so now we've got here 11, and we're going to multiply that by 4/9. Okay, so it helps here to remember that 11 is really 11 over 1 times 4 over 9. So we'll multiply across the top and across the bottom. So this is equal to -4 plus, and now let's do this. 11 times 4 is 44. 1 times 9 is 9. So plus 44/9. At this point, it would help us to have a common denominator. So I will multiply -4 by 9 over 9. Okay, so over in side work, where am I going to put side work? Over here in side work, I'll put -4 over 1 times 9 over 9. Right, and that's equal to -36/9. And that's just -4 written with a denominator of 9. So we'll rewrite this equals -36 over 9 plus 44 over 9. Well, what does that equal to? Well, we need to basically subtract 36 from 44. So we'll do 44 minus 36. and we will borrow 14 minus 6 is 8. And so what I'm left with here is 8/9. Okay, so what is 8/9 as a decimal? Well, let's see what we can get when we do a division here. 8 divided by 9. Well, right away I can't put 9 into 8, so I've got to put a decimal, so it's less than 1. Put a decimal and say, well, how about 80? Well, sure. 9 goes into 80 8 times. 8 times 9 is 72. And 80 minus 72 is 8. Bring down a 0. 9 goes into 80 8 times. And just understand it's going to continue 0.888888 like that. And so what we can write is we can say, well, this is equal to 8, or 0.8 rather, repeating. Okay, and that'll give us a place to put it on the paper, right? So either we'll plot 8/9 or we'll plot 0.8 repeating and get as close as we can using pen and paper. So we found the x coordinate, that's 0.8 repeating. Now let's find the y coordinate. Where do I want to do this work? I'll do this work over here. So here's the y coordinate of campsite B, and that is equal to, remember we're moving from down here up, because we're going up to campsite C. So we will add, we'll say, well, what was the y coordinate for campsite A? Whatever that is, we're going to add to it because we're going up, plus, open parentheses, absolute value. And now I need to find the difference in the y values of campsites A and C. So y sub A minus y sub C, close parentheses, close absolute value, multiplied by the fraction, which would be 4/9. And we will close the parentheses on that. Now we just need to substitute in the values. So here for y sub A, it was -9. -9. So we'll put in here -9 plus, open parentheses, absolute value. And now the y value of A is -9 minus the y value of C, 8. Close the absolute value and multiply by 4/9. So we're still humming along. Now this is equal to -9 plus, open parentheses, and let's do this. -9 minus 8 is -17. The absolute value of -17 is +17. So we just get rid of the absolute value and write 17 times 4/9. And so 17 is really 17 over 1 times 4/9. So we're going to do that multiplication here in a moment. But first we'll write equals -9 plus. All right, so now we've got to multiply 17 times 4, which is not one that I've ever memorized. So 7 times 4 is 28, carry the 2, so this is 68. So we'll write -9 plus 68/9. It would be helpful to have -9 with a 9 in the denominator, so I'll multiply -9 over 1 by 9 over 9, which will give me -81 over 9. So I can rewrite -9 as -81 over 9. So let's do that. Equals -81/9 plus 68/9. Okay, so we have negative 81 and we're going to add 68 to it. That's basically like subtraction where the result is negative. So we'll do 81 minus 68 and we'll have to borrow. 11 minus 8 is 3. I don't know why I started writing an 8. 11 minus 8 is 3. And 7 minus 6 is 1. So that gives me negative 13 ninths. Okay? And now what we do is we just turn this improper fraction into a mixed fraction and then into a decimal. Okay? So how many times will 9 go into 13? Once, and it leaves 4 as a remainder. So this is equal to negative 4, or I should say negative 1, negative 1, and 4 ninths. Okay? Well, what is that as a decimal? Because that doesn't really help me plot it. Well, we can turn 4 ninths into a decimal. Let's see what it is. We have 4 divided by 9. Can't put 9 into 4, so we add a decimal point and say 40. 9 goes into 40 4 times. 4 times 9 is 36. And this is just going to continue forever, because now we're going to go back into 40, so it'll be 0.44444. So I can say that this mixed fraction is equal to negative 1.4 repeating. So now I've found both the x coordinate, which would be 8 ninths or 0.8 repeating, and the y coordinate, which is negative 1 and 4 ninths or negative 1.4 repeating. And I just have to plot those 2 points. So what I'm going to plot now is point B at 0.8 repeating, comma, negative 1.4 repeating. Okay, that's what I'm going to plot now, because that would be campsite B, and that's where the picnic tables are. So let's go find those coordinates. 0.8 repeating, that's almost 1 on the x, and then negative 1.4, that would be down here. So somewhere like right there is where I think it will be. Okay, and let's see if we're right. We need to get a pencil to shade this in. Let me shade the path in using orange. Let's see if I've got a longer ruler here. Maybe not. Will this reach? Yeah, this almost reaches. That'll work. I just need to connect the dots here real quick. All right, so I'm going to connect the dots, and then I'll come back and shade it in better. Okay, do you notice how that line passed right through that dot? That means we did it correctly. So let me go back here and fill this dot in a little bit more. This is campsite B, right? So this right here is campsite B, located at 0.8 repeating, comma, negative 1.4 repeating. And this is where the picnic tables are. So this is campsite B, and also picnic tables. So this is where the meeting place is according to the problem. Okay? And that is how you do the first one. Not too bad at all. Now the second one is fun, because on the second one we're going to take a road trip. All right, so let's take a look at the problem. Actually, I might have an image that I can show here. It says you and your friends are planning a summer road trip to San Francisco, California. Sorry. You and your friends are planning a summer road trip to San Francisco, California from Palestine, Texas. You plan to stop to pick up a friend in Amarillo, Texas, which is 1/9 the distance from Palestine to San Francisco. If San Francisco is located at S, which is -12, 14, and Palestine is located at P, which is 10, -9, what are the coordinates of your friend in Amarillo, which we'll call point A? All right. So again, I've got this printed map, but let me see if I can show a full color photo. Okay, so here comes the full color map. All right, so we are traveling from Palestine all the way to San Francisco. And what we're going to model, we can't do all these curves here. We're going to model a straight line path from Palestine to San Francisco on our paper. And then we'll find where Amarillo is along that path. It's going to be somewhere over here, okay, over near the panhandle of Texas. Okay, so that's a physical, or at least a map presentation of what we're going to do. Let's go back to our problem. Okay, so very first thing we need to do is plot the points that we're given. First, we'll plot San Francisco. That's our end point, and that's at -12, 14. So that would be over here at -12, 14, right here. Okay, and this would be point S, which is -12, 14, and that is San Francisco. San Francisco. All right, and we're starting in Palestine, which, as you saw on the map, was to the southeast of San Francisco. San Francisco is in the northwest United States, and Palestine, relative to San Francisco, is in the southeast. Let's take another look at the map just so you've got a good depiction in your head. Okay, so San Francisco here is in the northwest United States, and we're traveling to San Francisco from, relatively speaking, the southeast. So we're going to the left on the x-axis, we're going west, so to the left on the x-axis, and we're going north on the y-axis, or up. So when we get back to our problem here, we have to keep that in mind because it changes what we're going to do. Okay, but first we got to plot the Palestine point, and Palestine is located at 10, -9, and that would be over here at 10, -9, right here. Okay, and this would be point P, which is at 10, -9, and this is, this is Palestine, Texas. All right, Palestine. Okay, and it says we got to pick up our friend in Amarillo. So as we go from here all the way to San Francisco, we have to stop somewhere in here and pick up our friend. And the fractional distance that we have to pick the friend up at is 1/9 the distance from Palestine to San Francisco. So we're starting down here in the bottom right, and we're going to move up into the left to San Francisco. So let's keep that in mind as we do our calculations. Well, what are those calculations? Well, let's do the x first. So x sub a, which would be Amarillo coordinate, x coordinate, is equal to, now think about what you want to do here. You want to start at x sub p, which is Palestine, and we're going to go to the left. So on the number line, we're going to go negative. So we need to subtract out our fractional distance. Okay? Because before we were adding, now we're subtracting out the fractional distance component. That's open parentheses, absolute value bar, and we need to sub in the difference between x sub s and x sub p. So the x values of San Francisco and Palestine, we're going to take the difference of those, then take the absolute value of that difference, so we have a positive number, and multiply that times 1/9. All right? So this is this stuff in parentheses. This is the fractional distance, and to find the location, you subtract that fractional distance from x sub p because you're going this way. That's why we're subtracting it from x sub p instead of adding it to x sub p. If we were adding it to x sub p, it would mean we were moving this way, headed towards New York or something. All right, but we're going this way to San Francisco. So now let's substitute in our values. X sub p was 10 minus, open parentheses, open absolute value, x sub s, that's negative 12, minus x sub p, which is 10, so negative 12 minus 10 in the absolute value right there, times 1/9. Close the parentheses off, and that is equal to 10 minus, open parentheses. Now, negative 12 minus 10 is negative 22. You take the absolute value of negative 22, and you get positive 22. We can drop the absolute value bars at that point, times 1/9. So that's 22 over 1 times 1/9. Okay, so let's go ahead and rewrite 10 minus 22 times 1 is 22. 1 times 9 is 9. So 22/9. Now, wouldn't it be nice if we had a common denominator? Yes, it would. So, look, we can do this one in our heads. Just multiply 10 over 1 by 9 over 9, and you get 90 over 9, and that's just 10, okay, because 90 divided by 9 is 10. 90 over 9 minus 22 over 9. Okay, so what is 90 minus 22? Well, it is 68. All right, so this is equal to 68/9. And if you, let's turn this into a mixed fraction. How many times will 9 go into 68? 7 times. So this is equal to 7, and that's 7 is 63, okay? So between 63 and 68, there's 5. So it's 7 5/9. Okay? So we can now estimate the decimal that would represent by dividing 68 by 9. See what we get. So 9 goes into 68 7 times. 7 times 9 is 63. 8 minus 3 is 5. Put a point and bring down a 0. 9 goes into 50 5 times. 5 times 9 is 45. And here we're going to start the cycle where we just keep getting 5 as a remainder. So it's going to be 7.5 repeating. So this is 7.5 repeating. Okay, so that's the x component, 7.5 repeating. So now we'll find the y component. So this is the y component of Amarillo, and that is equal to, think about what we're doing now, because this is different. So for the x coordinate, we were moving to the left. So we subtracted the fractional distance from the x coordinate of our starting position. But now, for the y coordinate, we're actually moving up. So we want to add. Okay, so we'll take the y coordinate of our starting position, so y sub p, plus the fractional distance. So you just have to make up your mind what you need to do. And you know, you might make a mistake. I certainly have. You just go back and fix it. So open parentheses, absolute value, and now we need to find the absolute difference in the y values of San Francisco and Palestine. So y sub s minus y sub p and close that absolute value, multiply by the fraction, which is 1/9, and then close the parentheses. All right. So now let's substitute in the values. Y sub p is -9. Okay, -9 plus open parentheses, open absolute value, and now y sub s. So that's San Francisco's y coordinate, 14. Positive 14 minus the y coordinate of Palestine, which was -9. So it's minus -9. So we've got a minus minus situation. We'll deal with that. Again, times 1/9. Close the parentheses off. Okay, so this is equal to -9 plus open parentheses, absolute value, and now 14 minus 9 is 14 plus 9, and 14 plus 9 is 23, okay? So this is the absolute value of 23 times 1/9. And remember, the absolute value of a positive number is just that number, okay? So the absolute value 23 is 23. So we can say equals -9 plus. So 23 times 1 is 23, and 1 times 9 is 9. So 23/9. Let's go ahead and get 9 in terms of with 9 in the denominator. So we'd multiply top and bottom by 9, and we end up with -81/9 plus 23/9. Okay, so we basically have to subtract 23 from 81. 81 minus 23. And that would give us 8 and 5, 58. Okay, so this is -58 equals -58/9. So what is that as a mixed fraction? Well, 9 goes into 58 6 times, because 9 times 6 is 54. So we got 6, and then between 54 and 58 there's 4, so 6, so it should be -6 and 4/9. Okay, that's what I think. And so let's check that by finding the actual estimated decimal. And so we can do that by taking 58, right, and dividing by 9 over in side work. 9 goes into 58 6 times. 6 times 9 is 54, right? And 58 minus 54 is 4. So we put a point and bring down a 0. 9 goes into 40. Let's see, 4 times? 36, yeah. 4 times 9 is 36. So 40 minus 36 is just 4, and we will continue that process forever. So it's 6.4 repeating. Right, so this is equal to -6.4 repeating. So this is equal to -6.4 repeating. So now we found the x and y coordinates. Our x coordinate is 7.5 repeating, and let me write this down somewhere. So we found Amarillo. So Amarillo is located at 7.5 repeating, comma, -6.4 repeating. All right, so let's locate that. 7.5 is about right here. And I need to go down to -6.4, which is about right here. And so I think my point should lie somewhere about right there. Okay, that's where I think the point should be. And let's hope that it is. Let's take our orange marker and let's draw in these points. I'm going to need a longer straight edge. Okay, so I'm just connecting dots here. Okay, so let me draw that in a little bit darker now that I've got it. Okay, I think we're going to hit it this time. We have succeeded. Look at that. So our line passed right through that point that we plotted. You always want to plot the point first because it leaves kind of like the sense of tension. As you draw in that line, you're trembling, hoping, oh, I hope it goes right through that point. So this is in fact Amarillo. So this is where we're going to stop and pick up the friend. So this is A, open parentheses. And I think, the best way to do this is to express this as, instead of 7.5 repeating, comma, negative 6.4 repeating, let's go ahead and put it in improper fraction form. So point A, the x-coordinate would have been 68 ninths. Okay, comma. And then the y-coordinate, before we turned it into a decimal here, was negative 58 ninths. And that is Amarillo. Okay, so this is Amarillo. And this is where we're picking up the friend. And then y'all are all headed to San Francisco for a fun trip. Alrighty. So that's number 2. Pretty neat. And now for number 3, guys, it gets so exciting, we're going to need to contain ourselves. Our excitement, that is, because we are traveling to Carlsbad Caverns, right? If you have been here, you know how cool this place is. What we're going to do is we're going to go in the natural entrance. It's this huge opening if you've ever been there. Bats fly out of it. And then we'll travel down deep past Devil's Springs, the Whale's Mouth, the Natural Bridge, the Devil's Den, the American Eagle, the Bypass Tunnel, the Baby Hippo, the Main Corridor, Three Little Monkeys, the Iceberg, okay, the Veiled Statue, all the way down into the depths of the cave to the frozen waterfall, okay? If you've ever seen this place, you know how cool this is. So we're going to the frozen waterfall, right? And we're starting up here at the natural entrance. So if you look at this, we're kind of going down and to the right, right? Down and to the right. So we're moving this way on the x-axis and this way on the y-axis. So to the right on the x-axis, so we're going to be adding on the x-axis, but on the y-axis we're going to need to subtract that fractional distance from our starting y-coordinate because we're going down, all right? Down into the depths. Let me show you a better picture of that, by the way, here after I read this. You are spelunking in Carlsbad Caverns. Okay, just on the other side of the Texas-New Mexico border, up near the Panhandle area, you got Carlsbad, New Mexico. It's a very cool place. I hope you go there or have been there. You are spelunking in Carlsbad Caverns. Spelunking, it's a word that means to explore the cave. You and your friends are headed into the mouth of the cave on foot and down into the dark depths. It's a very long journey, nearly 2 hours on foot. Okay, so you need to rest along the way. You all talk to the guide, and she suggests stopping 5/7 of the way down into the cave at the Three Little Monkeys Cave Formation. All right, so right here, I want to show you where that is. So here's the entrance, and you go down, 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 and right here is the Three Little Monkeys, and you see that's about 5/7 of the way down to the frozen waterfall. What else does it tell us? If your starting position at the cave's natural entrance is E, negative 14, 15, and the deepest point of the cave is the frozen waterfall, f 13 comma negative 12, what are the coordinates of your resting place at three little monkeys, point T? Well, cool. I mean, this is just cool. Let's look at a better picture of the Carlsbad Caverns cave system. Here, let me bring this up. Okay, very neat. So you can see here we're starting at the natural entrance, and you'll go down, and over here it's got the depth, so it's 200 feet above sea level, or 200 feet, I don't know if it's 200 feet above or below. I guess it's 200 feet below sea level, all the way down to 800 feet below sea level, if I'm reading that correctly. This distance you're traveling is as tall as the Space Needle. Okay, very tall. So it's a long way down. Guys, this takes forever, and it's a fun walk, though. It's very cool inside the cave, and it's beautiful. It's a very cool place to be. So now let's go back to our problem and actually solve it out. So we're just going to model this picture, by the way. It's not going to look just like the picture, but it's going to be a model of it. I don't know about you, but this is fun. Okay, so we are spelunking in Carlsbad Caverns. All right. In class, I'll try to show more pictures of what it looks like inside the cave, or maybe we'll watch a little movie about it, a little documentary. Okay, if we have time. So let's plot our points. Nothing's changed. We're plotting our points. First step. And the natural entrance to the cave is located at negative 14, comma 15. So let's go to negative 14, comma 15, way up here. Okay, so negative 14 on the x, 15 on the y. I'm going to need a longer straight edge for this. And this is the natural entrance, and that is point E for entrance, open parentheses, negative 14, comma, positive 15. Okay? And now the other position, the place where we're going to stop, is at the very bottom of the cave, the frozen waterfall at f 13, comma, negative 12. So we need to go over into this quadrant to find 13, comma, negative 12. Right here. Okay? So this is, what was that called? Point F? Yeah, point F. 13, comma, negative 12. Okay, and this is the frozen waterfall. Let's write that in. Frozen waterfall. It's just like a stone formation made out of limestone that looks like a waterfall. Frozen waterfall. Very cool. All right, so up here, this was called the natural entrance. The big mouth entrance. And y'all are young, you can take the big mouth entrance. Some of the older folks will take the elevator, but y'all will take the natural entrance. It's really cool. It's huge. Okay, so what we want to do is travel 5/7 of the way down. So like this, down here. And before we get down to the frozen waterfall, we're going to take a break. Remember, the guide said to take a break 5/7 of the way down at the formation called the Three Little Monkeys. All right, so that's where we're going to rest. And that's 5/7 of the way down. So that's the position we're looking for, point T. All right, so we got to do the math. Well, let's do the math for the x variable, and let's think about what we're doing. So we're here, and we're going to move to the right. So we'll be adding the fractional distance to our beginning x coordinate. All right, so here is the x coordinate of the three little monkeys. All right, so x sub t is equal to the starting coordinate, which would be x sub e. And we're going to add the fractional distance plus open parentheses, absolute value. And now we'll find the absolute difference between the starting and ending x coordinates. So this would be x sub e minus x sub f the frozen waterfall coordinate x value. Close those absolute values, and then multiply all that by 5/7. Okay, close parentheses. All right, so let's substitute in our values and get to work. So this would be x sub e is -14. -14 plus, open parentheses, absolute value bar, and now x sub e again, -14, minus the x sub f coordinate, and that would be 13. Okay, so positive 13, -14 minus 13. Close those absolute values, and then multiply the product, okay, or multiply the difference there, the absolute value there, by 5/7. All right, so here we go again. We've got that beginning x coordinate, -14, plus, now we got to do -14 minus 13, which is just 14 plus 13 with a negative sign. So that would be 7 and 2, -27. So the absolute value of -27 is positive 27. So we just go in here and put 27 over 1 times 5/7. Okay? So we just need to multiply 27 times 5. So what is 27 times 5? Well, 7 times 5 is 35. Carry the 3. 2 times 5 is 10, plus 3 is 13, so 135. All right, so let's rewrite this equals -14 plus 135 over 7, because 1 times 7 is 7. Okay, now I got to turn -14 into a number with 7 in the denominator, so I've got to multiply -14 by 7 over 7. -14 over 1 times 7 over 7. All right, so what is 14 times 7? Let's see, 4 times 7 is 28, and that would be 98. All right, so this is equal to -98/7. So let's rewrite this. And instead of -14, I'll write -98/7 plus 135/7. Okay, so now I just basically have to subtract 98 from 135. I don't know if you can just see it, but it's 37, right? It's 37 because you just have to go up 2 to 100 and then plus 35. But if you didn't see it, we'll do it over here. 135 minus 98. All right, we'll borrow 0, 2, so that would be 12, and then 15. 15 minus 8 is 7. And 12 minus 9 is 3. 37, all right? So this is equal to 37 over 7. Well, what is that as a mixed fraction? Let's see, 7 goes into 37 5 times. So it's 5 and then 2 remainder, 2/7. 5 and 2/7. That's our x coordinate at the three little monkeys. But let's turn that into a decimal. Now, when you divide 2 by 7, you're going to get an irrational number. So we'll just take it out to a couple of places. 2 divided by 7. You're going to need to add that decimal point. And so 7 goes into 20 twice. 7 times 2 is 14. Okay. 20 minus 14 is 6. Bring down a 0. 7 goes into 60 8 times. 8 times 7 is 56. Okay, and then you do 60 minus 56, that's 4. And now you be 7 goes into 40 5 times, which would be 35. So we'll stop there. Let's round to the nearest tenths place, which would be 0.3. Okay, so what we'll say is, we'll say that this is 5 2/7 is approximately equal, okay, approximately equal to 5.3. All right, because I'm going to round to the nearest tenths place. All right, so 5.3 is the x coordinate. And let's go down here and do the y coordinates. So if I want to find y sub t, the three little monkeys coordinate for the y, I need to think about it. I'm going to start up on top at 15, and I'll be going down to -12. All right? So what I've got to do is I have to subtract the fractional distance from the 15. So over here, see, I was adding to the x, but I'm going to subtract from the y. So here we'll put y sub e, that's my starting position, minus, okay, because I'm going down the cave, minus, open parentheses, absolute value. And now I need the y coordinate again, the absolute difference in the y coordinates. So y sub e minus y sub f. Close those absolute values and close the coordinate. Whoops, we're not closing the parentheses yet. Lo siento, I'm sorry. So close the absolute value and then multiply by the fraction 5/7. All right, then close the parentheses. My bad. All right, so now we'll substitute in our values. So y sub e was 15. So we'll put in here 15 minus, open parentheses, open absolute value bar. Now again, y sub e was 15 minus the y value of the f coordinate, which was -12. So that's minus -12. So minus minus, we'll deal with that, times 5/7, close parentheses. All right, so this is equal to 15 minus, and now we need to do 5, okay, minus minus is plus, so we'll do 15 plus 12. All right, and that's just 27. So 15 minus, open parentheses, 27 over 1 times 5/7. Close parentheses. All right. So we just have to multiply 27 times 5. 27 times 5 is 35. That's 135. And so we have 135/7 inside here. So now we have 15 minus 135/7. All right, so we got to turn 15 into a number with 7 in the denominator. So we need to multiply 15 times 7/7. So 5 times 7 is 35, and that would be 105/7 equals 105/7 minus 135/7. So we have to find 105 minus 135, and that would be like subtracting 105 from 135, with the result being negative. Okay, so 5 minus 5 is 0, 3 minus 0 is 3, and 1 minus 1 is 0. So it's -30. This is equal to -30/7. Well, what is that as a mixed fraction? 7 goes into 30 4 times, with 2 as a remainder, so -4 2/7. Well, what is that as a decimal? Well, let's try 30 divided by 7. Okay, let's see what we get. 7 goes into 30 4 times. 4 times 7 is 28. Leaves 2. Put a decimal place and bring down a 0. 7 goes into 20 2 times. That's 14. Okay, leave 6, bring down a 0. 7 goes into 60 8 times, and that's 56. And we can stop there. We're just going to round to the nearest tenth. So this is approximately equal to negative 4.3. All right, so here are my coordinates for the 3 little monkeys. My coordinates for the 3 little monkeys, point T, are approximately 5.3, comma, negative 4.3. Close parentheses, all right? These are approximate values. Let's go find those. 5.3 on the X, that's over here, about right there. And then negative 4.3 on the Y, about right there. So I think my point should be like right there where my pen tip is, right about there. That's about where it should be. Okay, well, let's see if it is. So now, I'm going to have to use I'm going to have to hunt around here for something. Piece of paper here. And we'll draw in this distance. Right? Just trying to get this line drawn here. All right, so now I can use my straight edge. You gotta take your time and draw in this line. Right, and we're passing right through that point, which is good. Okay, so there's my line. All right, so this point right here, that is going to be point T, and we'll go ahead and use the non-approximated improper fractions here. So instead of putting 5.3, I'll put 37/7. This is the exact value, comma, and then negative 37. And that is the 3 little monkeys. Three little monkeys, and that is where we're going to rest. Okay, 3 little monkeys, and this is our rest stop. Okay, well, how cool is that? So in this example, or in this video, we have gone to a campsite. We have traveled to San Francisco, and then we went spelunking in Carlsbad Caverns. And we did all that with pencil and paper using the wonderful tools and techniques of geometry. So, I hope you found that fun. I know I did. There is so much to learn here. But just by practicing this technique of fractional distance, I think you will grow to understand this whole process very well. All right? So thanks again for watching. Guys, if you found this video informative or insightful, interesting, helpful at all in the slightest, please give it a thumbs up. It has taken us exactly 59 minutes and 20 seconds so far. Go ahead and leave a thumbs up there. Leave a comment in the description if you have a comment you'd like to, or leave a comment in the comment section if you have a comment you'd like to make or a question. And if you have not already, please subscribe to the channel so you are always updated when I publish new math videos. Thanks.